me. Um, Literally just 5 minutes ago, I was throwing in some last analyses, so this is very much hot off the press, um, in more stressful ways than pleasant ways. Um, but I'm basically going to talk about a little bit of my dissertation research that was in the Amazon of Ecuador. I had a really hard time choosing what to present for this Tropilunch, so I kind of had a TBD up on the Tropilunch forum for months until last night when it kind of all came together. So I'm basically going to just highlight two key messages, and you can ignore graphs if you don't want to look at graphs. You can ignore pictures if you don't want to look at pictures. But this is what I want you to kind of take home from everything. That self-determination and resource management is important for maintaining biological and cultural diversity in the face of change. And that partnerships and participatory research are two important ways that we as researchers or conservation practitioners can really help support self-determination. And I'm going to demonstrate those 2 points in different ways based on my research in Ecuador with a group called the COPAN. They are located in the Amazon basin. So this is South America. You've got Ecuador on the left. So this is the western Amazon basin and eastern Ecuador. Just to quickly kind of orient you. And basically all of this area into Colombia, a bit into Peru, was Copan ancestral territory. There were no boundaries back then. The Copan lived in large and small groups, some up to 20,000 people in a community, and they stretched from the Andean foothills down into the lowlands of the Amazon. So this is kind of more picturesque, what you would think it looked like back in the day, and you can still find pockets of places that look like this. It was a people that were very dependent on the environment for their survival, and they reciprocally kind of co-reproduced one another. So you can see the material items on this elder's chest. These are bones from nocturnal curassow, so a fairly rare bird, and he's collected quite a few in his years. And these pictures were just taken recently, so the culture is still thriving, if not changed in many different ways. And the main thing I wanted to highlight here is that the Copan continue to produce and reproduce their territory, despite all of these drastic changes that have happened within their territory. They still encompass a huge amount of traditional knowledge about their area, and a lot of this is encoded in their language. So 60 to 70% of their language is unique words to their environment. But like many indigenous populations around the world, disease decimated their population. They went from 20 to 30,000 to 400. So completely wiped out. And then a second wave really hit them beginning in the 70s with oil exploration. In 1972, a road linked Quito to the lowlands of Ecuador and brought with it huge waves of colonization. They essentially lost all of their territory, mainly due to roads, infrastructure, land reform change. The government really promoting, saying this is open lands, take as much as you want for whatever you want to do. So here are some of the roads that are still, this is actually a more recent image, so this process still continues today, stretching further and further west and deeper into the Amazon. But the Copan are a very persistent, resilient people, feisty, some people might call them, and they've adapted different strategies for regaining some of their territory. Some of them are political, so they work with the Ministry of Environment, they work with international NGOs to say that these territories are important, that they're their ancestral territories, and that they should have legal rights to them. This photo I actually took just in January of them gaining title to another 50,000 hectares. So the process is ongoing, it's been going on since the 70s. And they take alternative approaches as well. They're not afraid to grab their spears and march, hit the streets, overtake oil platforms. They just kicked out 52 mining concessions within their territory. So when the need arises, they are always there to kind of step up. And this is what their territory kind of looks like today. Using the same two pictures from below, all the dark gray areas are Copan territories. Some big, up to 150,000 hectares, and some quite small, less than 10,000 hectares. And these processes are still going on today, and that's the kind of dynamic point that I want to keep making. This you can't see up there, but that's 1990. And I'll try to toggle between these a few times. So you can see just in 20 years, that's 2010, and I have more recent data, but you can see that this process of colonization continues. Oops, and continues to isolate communities like Doreno, which has maintained most of their forest cover, 95%, but they get oil palm coming in, all kinds of agriculture, and it just creates more and more of these little isolated blocks. So my thought was, instead of getting really into the nitty-gritty details, I'll do a little bit of that later of my dissertation, but first I just wanted to present a little bit about my approach to working with these people. Since it is a bit unique, and I think it's important for people who want to engage with Indigenous peoples to kind of think about some of these aspects. So my first approach whenever I started working with the Kofan was to build social capital. And what that means is doing a lot of things unrelated to what I'd really set out to do. This is drinking beer, taking ayahuasca, hunting, fishing, spending time in the territory, getting to know people, building friendships and trust. And it's an important step that I think a lot of conservationists and researchers skip. You jump in, you really want to have your goals, you want to ask people questions, and it can be difficult for an Indigenous person in that context to really respond in ways that you want. So if you show yourself as just wanting to be there and participate, learn from the community, take your time, and then let the research questions kind of flow naturally from that. So my dissertation research builds on about 5 years of doing that. Spending time in the community, doing whatever they want, listening to what they have to say without really an agenda. So thinking about their perspectives, what motivates them. A lot of my research about hunting, which I'll describe later, has come from thinking in different, I've talked to Susan a lot about this, but epistemologies and ontologies. They talk about the forest as being full of these spirit beings and people who can call game from different locations. And if you overlook that, you're going to miss a huge part of what hunting is to the Kopan. And ultimately, my research is about empowering local decision making. So this is a community meeting in Savolo, and my goal is to present information that they can use at these kind of information, or at these kind of meetings, and really to not push an agenda. So if I go in with different research, I'm going to present different sides of the table. I'm not just going to say, you need to conserve your animals because tapir are important, and my agenda is biodiversity conservation, so you can't hunt. It's going to be to give them all kinds of information that they can say, no, you're wrong. The government was guilty of this because they came in and they said just that. You're hunting too much tapir. You're hunting unsustainably. And the Kopan said, no, we've been hunting the same way for a long time. Don't tell us what to do. So a lot of this research is validating Kopan knowledge in scientific ways that the government can understand, but also that empowers their own decision making and their own knowledge and skills. And the last one, really quickly, is just committing to a long haul. I know it's not always feasible when you want to do a project for 2 years, but it's important to think about what your engagement's going to be as soon as you start a project. I'm going on about 8 years with the Kopan now, and I continue to keep going. And spreading money out over time, just thinking about how to continue engagement is really important. Going back and going back and going back will get you a lot closer to the answers that you want, rather than the mischievous lies and whatnot that can often happen when you rock up in a community and start asking questions. So that's kind of the foundation, and then it moves into my specific participatory research approach. So using these guiding principles of partnership, how did I think about my actual research in Savolo? So this is the community I'm going to focus on here, the most far away into the Amazon you can get in Ecuador, just about. There it is again. It's about 150,000 hectares. This is the Aguarica River, so it's a main whitewater tributary, and you've got a series of blackwater rivers that are large and great for fishing. A little bit closer up. So the community that I lived in is here, and then there's sporadic smaller houses and communities within the territory. Here it is from above, and the main thing is that it really became a home for several years. me. That's my house. And through that, 5 years or so, I gained permission to build a house in the community and really kind of set some roots and made research that much easier. And a lot of friends who we go out hunting and fishing with. And there's the product of our hunting and fishing. And it's really about just sharing food and building these relationships so you can dig into the actual questions. Okay, I'm going in reverse order a little bit. I thought there was a video here. We know if there's sound. So the idea was here just to take you through the kind of the process of how you engage in a community. You're going to share food, you're going to cook food, you're going to hunt for food, and then you're going to be out here getting really excited when you see a group like this. These are white-lipped peccary, camera traps, and you can hear them munching on all kinds of good stuff, and you'll hear their click. Let's get that. So it was through this kind of process of engagement, of hanging out with people, going hunting and fishing, that I began to tease out a Kofan word that I had a really hard time understanding at first, called sepicho. And it means prohibitions, and people use it in a lot of different contexts. A lot of times when you're taking ayahuasca, they'll talk about the things you can't do before you take it. You have to clean and such. Women, when they're menstruating, they're strict sepicho rules of you have to stay here, you can't touch this food. But then there's this kind of more abstract set of rules that govern where, when, what, everything about forest life and what you can hunt and fish and gather. So there's probably 75 different rules, each in flux every single year. And they range from entirely protected areas where you can't hunt at all to a seasonal variation where I can, as a family, only kill 3 monkeys within this one area. So it's timed to when they're the fattest in their season, when these other fruits are fruiting. But it's a complicated set of rules, and I kind of laid it out very simply. On this is a hunting area, this is a no hunting area. There's all the rules interspersed within these areas. But you follow this river and you can't hunt, and then there's a series of landmarks that you can find in the woods that basically indicate roughly when you're kind of getting outside of that hunting area. And these are just pictures of dead animals, but interestingly, the Kofan word for food and animals is the same. So it's a nice kind of coupled system that you can really look at closely. And that was the focus of a lot of my dissertation research. So my main goal in supporting the Kofan self-determination was to look at how effective is this system for managing their game populations. People from outside, people from the government like to come down every month and tell the Kofan that they're not hunting sustainably. NGOs like to come down and say, we've done 6 months of research and you're hunting way too much. And they have this constant stream of information telling them that they're doing everything wrong, basically. And it really diminishes their self-determination. And they've come up with their own set of rules, but they constantly have people from the outside telling them that your rules aren't valid because they're not based on Western science. So my understanding was that this is probably a sustainable system. I did a lot of research into their motivations and these rules. And essentially they asked me to use some Western scientific tools to say, can you validate our system of management so that the government can stop bugging us? So that we can use this to leverage it for larger land gains. They're still in this active process of looking for land and territory, and we just kind of want this settled once and for all. And it was really kind of a prime opportunity because there was some data and research that they collected throughout the years, and then my own data over 10 years that we collected helped expand this time series to really look at changes in hunting and animal populations over time. So the first thing was obviously a list of sepicho and really understanding that, and then looking at hunting patterns, where, when, how frequently are they going hunting, what animals are they targeting, why are they going hunting, are they sharing, this whole bucket list of more of the social variables. And I'm still working through them all because there's a lot, but most people in Savalo are going hunting 5 times a week. They're heavily dependent on that for their livelihoods. They're only going to the markets once or twice a month, and it's for basics like maybe some rice, salt, soap. So the vast majority of their diet is coming from the forest, and I'm still working on some of the composition, what animals they're really targeting, when they're targeting them. So obviously there's seasonality. You get a lot more dependence on fish in certain seasons, a lot more dependent on game in other seasons. And here's a quick result of hunting for mammals in Sawalo. So you can see again the hunted areas here, and then outside the no hunted areas. This is that kind of buffer line of where you're getting outside the hunted line. And I didn't have any of these lines drawn into the maps when we were recording every single hunt or activity that they did. And we did a little over 1,500 unique hunting events. And they'd come to my house and we would sit down and map every single one out without a lot of these indicators. And you can still see that they're hunting well within all of the limits. And they are allowed to hunt on the Blackwater rivers. So we'll do that for fish and fruits and kind of start to see where they're using things, some temporality to it, and get a good feel for what the hunting pressure really is on the system. And then the flip side is how many animals are in the forest, where are they, how are their abundances changing over time. And so one of the tools we used was camera tracking. So again, everybody, I was basically just a coordinator. I helped find the cameras and they chose where they wanted to put them roughly. We kept it fairly random of a grid, and a lot of time walking really far into the forest. So we'd walk, I think I have a map of it, up to 15 kilometers in, so a 30-kilometer day, and about half of the cameras are off trail, so bushwhacking for 15 kilometers into the woods, crossing streams. It was a little bit more daunting than I anticipated. Lost a lot of weight. And these buffers are about 1 kilometer, so we tried to get a nice 2-kilometer buffer between each camera, which is good for medium to large mammals. So you get a good diversity of the things they're targeting for hunting. Got a lot of jaguars, healthy populations of jaguars, and a whole lot of other videos I can show later. And this just shows quickly species richness. So you do see a clear difference in the number of different species found at each location, represented by size and color, saying the same thing twice. But outside of the hunting zone, you get a lot more species crossing the camera. Inside the hunting, you get much fewer species, and you can clearly identify some of like the salt licks, for example. There's a salt lick right here, so that's clearly probably bringing in some animals and bumping up the richness. So hunting is having an impact. The real question is, how is it changing over time, and how are the animal populations actually changing? Oh, more videos. I'll just show a couple of seconds of this one. So we identified 35 different species that are walking through these. So these are all just land-based animals. Lots of tapir, lots of jaguar, lots of pigs, even some giant anteaters. And now some of the preliminary results. So my first thought was to model occupancy, and I was interested in this transition from hunting to no hunting, and so I represented that in distance from the community. So it's a bit of a rough indicator, but in every single one you can see as you move further away from the community, the chances of finding that animal go up. So there is a clear impact of hunting. That's collared peccary. You can't see the name up there. But it's clear that hunting is having an impact. And all this is really telling me is that this animal is found or it wasn't found. And a whole lot more. Oh, sorry, this is actually a little different. I'm combining 2 data sets here, which is also a bit rough because it's just been done last night. But it's looking at a camera trap study that was done in 2008 and then mine in 2010. the cameras were basically placed in the same location, the same number of days, and the same season. So you can see some shifts in occupancy over time. With where the red is this last year. Sorry, yes, the red is this last year, 2018, and the black is 2008. So in a lot of them, you'll notice some big jumps in occupancy in the sites that are closer. So the strangest one is the ocelot. We hardly had any registers of ocelots during our time, and yet in 2008 they were fairly high and fairly consistent. We had about 2 registered of ocelots our year versus 30 in 2008. So significantly different. Versus other animals that are staying relatively the same, the gray-winged trumpeter, jaguars, roughly the same, and collared peccaries are all kind of having that slight bump up, which would suggest that over time, perhaps you're having an increased occupancy in all of these animals. There's more animals at each of these sites over time. And then this is just a real quick, some activity patterns. So collared peccaries that are staying the same through time also are having the same activity patterns over time. Same with the gray-winged trumpeter. But you can tell that some animals are probably responding to an increase or a decrease in hunting pressure. So they're changing their activity patterns. So what was really interesting was these ocelots basically went down. There was hardly any ocelots in our year, but the short-eared dog, their populations skyrocketed. So it was basically the inverse. We had 2 registered of short-eared dogs in 2008, but some 50-some in our year. So they're all over these cameras, and versus hardly any ocelots. So now we're looking at maybe some overlap in time and territory to see what's going on with those 2 animals. So that kind of sums it up. A camera, it's kind of rough. It's just looking at occupancy. What are the changes over time between these 2 years? Distance sampling gets into a little bit meatier of the questions. So distance sampling is basically cutting a transect, a straight line, as straight as you can get, for X amount of meters, whatever you want to measure. We made up for how big Savolo is by making our transects a bit longer. So some transects can be 1 kilometer, ours were 10 kilometers. This study design was actually made in 2001 by the Field Museum. So the data goes back to 2001. We replicated again in 2008 and then 2018. So we basically just stuck with what they created in 2001 so we can clearly track changes over time. And what it involves is spending several days clearing a trail as straight as you can go, roughly 10 kilometers, so you can get a good amount of transect within the hunted area and a good amount of transect outside of the hunted area. And you have to cross a lot of rivers, and you sometimes get stuck on really high up on trees, avoiding beast nests. So it's a lot of walking. And these are what the trails look like. So again, this is the hunted area and the non-hunted area. So we're looking at changes along these trails in the density of animals. So how many animals are there per square kilometer along these trails?
Site.
Yes. So we did it primarily by sight. We also had them collect sound and track information. That actually wasn't one of the transect walks. I was going looking for food. But yeah, they don't take, the only thing they take is their pen and pencil and their gun for safety and a machete. So I can walk through some of the details of. So as you walk this transect, you're going to note your kilometer, so how far you've walked. So every 50 kilometers, we have a tag saying where you are basically, and they'll estimate between that 50 meters. And then you'll write down, I saw X animal at this meter at this time of day, and then you estimate an angle. So I'm walking on a trail that's going this way. I'm looking at this animal 45 degrees to my right, and they're at a distance of X, 40 meters. So then you bring that home and you crunch the data a little bit, and it tells you how close is that animal to the trail. So the main assumption with distance sampling is the closer you are to the trail, the higher the probability that you're going to see the animal. So that's fairly obvious. If I'm close to the trail and there's an animal there, I'm going to see it. If the animal's 100 meters in, I'm probably not going to see it. So you've got this monotonicity in this function that says, as distance gets greater from the trail, I'm not going to see the animals. And that kind of highlights here. So this is data on macaws. So as you get further and further up to 60 meters from the trail, the probability that you're going to see that animal goes down sharply. So the bulk of our detections are going to be within this 10 to 20 meter range. And then it falls down sharply, and then you do some other data manipulation. You group things differently. This is just for illustration. And then you can do quantile plots to see how well does this line fit that data, because this is going to give us our estimates of density. So for macaws, it fits pretty good. The more dots you have on that line, the better, basically. So you're using a variety of goodness of fit tests, because sometimes the data can be hard to manipulate and get these models to work. And then your output is basically something like this. And these lines came out really small, sorry. So these are macaws. This is density over time. So 2001, 2008, and 2018. And they're in two different areas. They're in a hunted area, and then they're in I wrote the Kofan word, is in a non-hunted area. So in the non-hunted area, the density is a little less than 4, and it stays steady over time. So that would be something that I would hypothesize to be true. They can't hunt this animal in a non-hunted area. So over time, the densities are staying roughly the same. Versus the non-hunted area, this red line represents the year that a rule came into place about that species. So in 2003, they said, we don't have any more macaws. We need to do something about this. People are hunting them for headdresses and whatnot far too frequently. So they came up with a rule that said only shamans, only elders, only people in the Dirigente, the president, can shoot a macaw with permission. So you can't just go out shooting macaws willy-nilly. You have to have a rule, and you will get penalized if you do that. So you start to see an increase in the first 7 years, and then a significant increase in further years. So now there are macaws everywhere. In August, it can be horrible. It's just all you hear, and they're dive bombing your boat, and it's not a very pleasant thing. So this is one way of proving with distance sampling that perhaps their system is actually having an impact. There's a clear rule, and there's a clear increase in density over time. And then it's basically the same thing for a whole bunch of different species. Some control species, so ones where there wasn't a prohibition, and then some where they've instituted some kind of new rule. So these rules change over time. So there were rules previously, but this rule said, for example, you can only hunt 3 of these animals in the month of May per family. So before you could take 10, now you can only take 3. And again, you start to see a little bit of an increase, not too significant. Again, the same, you get, shoot. What did I do wrong? This was the bad part about just doing this 10 minutes ago. I put the line in the wrong graph. There is no regulation for howler monkeys. There's only a regulation. It's supposed to be in that same year, 2005, for the woolly monkeys. You can only hunt 3 woolly monkeys in 2 different months of the year. And so you get a pretty steady no change in the non-hunted area, no impact of the rule, versus potentially a slight increase. They might have been hunting too much in 2001 through 4, and then they changed the rule. That one's a little bit hard to tease out. And then these are 2 animals that I noticed significantly on that's the wrong animal. Okay, just ignore that picture. that's a paca. It's supposed to be a rodent that looks pretty small, similar to this one, the green acuchi, but it's an agouti, and it's a little bit bigger than the acuchi. But both of them significantly decline in the hunted area. The non-hunted areas, our densities stay roughly the same, which we would expect, but something is tanking these populations. It could be jaguars, it could be dogs, it could be people just overhunting. So it could be a lot of different things. But we also found the same result in occupancy of the camera traps. We hardly had any registers of Akuchi, versus 10 years ago we had a ton. and collar peccary as well. Again, kind of the same story. They're staying relatively the same in the non-hunted area, so that area is functioning, and potentially a slight increase after that rule was instituted. So what does all of this disparate data mean? Good question. I mean, a lot of these distance sampling models need to be refined and worked on. The confidence intervals, you might have noticed, are pretty big for most. And I'm working with someone in the Department of Statistics on how we can tighten up those models a little bit, how we can model that detection function better without the kind of standard models that is used in distance sampling. Because we have so much data, we can use a detection function that fits the data a little bit better. And I think roughly the same trends will occur, but we'll be able to pull those confidence intervals in a little bit. And then the main thing is that the Copon connection with the forest is something that we have to try to maintain over time. And one way to do that is recognizing their knowledge and their ability to self-govern themselves. So if we take that away from them, then they might have less interest in the forest, they might want to hunt and fish less, and it has serious implications for the conservation of these characters. You aren't going to take care of the forest, you're going to let people come in, you don't see a direct link between your livelihoods and the forest. So that's what all this research really is ultimately it'll be a sheet of paper at the end saying that the Copon can hunt sustainably and manage according to their own rules. And then there's the whole suite of engaging with these people and creating friendships and preparing for new research opportunities because of this kind of long-term partnership. But yeah, it was a lot of fun. Questions?